artificial intelligence systems for supporting video surveillance operators on international airports. Abstract. International airports come under critical infrastructure. Therefore, each security system consists of many crucial elements aimed at guaranteeing the safety of passengers and airport workers. There is a need to develop the safety aspect to a highest level. This paper aims to analyze the possibilities of supporting video surveillance operators at the airport with modern artificial intelligence (AI) solutions to obtain the best research result. Different functionalities were tested simultaneously. The first is based on built-in camera software to detect loitering, and the second is based on the already used CCTV system. In addition, practical tests have been carried out at the International Katowice Airport under actual conditions. The test results show that AI systems can help video surveillance operators perform their duties, but they must be refined. Introduction. Along with the increase in the number of passengers and visitors to airport, it was necessary to adopt safety standards to new threats resulting from geopolitical situations independent of airport. The proceeding of September 11, 2001 in the United States of America were a breaking through point in the development of technology and legal regulations aimed at ensuring the required standards of safety flight operations. Among the numerous security measures used in the airport security system, CCTV occupies an important place, which along with the development of AI-based technology is an important tool that supports the work of airport security. 1.1 Airport Security System. The airport security system consists of many formal and technical elements aimed at detecting a threat to flight operations performed at the airport. These are such elements as legal system, organization of security at the airport, and equipment supporting the work of airport security operators. With technology development, the risk of an act of unlawful interference in a broad sense also increase, which is an unlawful and intentional act consisting of the use of violence against a person on board during the flight of an aircraft, if this act may endanger the safety, destroying an aircraft or causing damage to it that prevents a flight or may pose a threat to the safety of the aircraft, placing on board an aircraft an object, device, or substance that may endanger the health or life of passengers or crew, or destroy the aircraft or cause damage to the aircraft that may prevent its flight or pose threat to the safety of the aircraft during the flight. Hijacking of the aircraft without crew and passengers on board, including for the purpose of using the aircraft as a tool of aerial terrorist attack, destruction to or damage to astronomical ground or airborne equipment, interference with operation or use of violence against a person operating such equipment, where these causes significant disruption to air traffic or endangers civil aviation safety, providing false information that causes a threat to person and property in air transport, destruction or serious damage to airborne facilities, disruption of their operation, or use of violence against the operator of such equipment, where this causes significant disruption to air traffic or airborne operations or endangered civil aviation safety. ICAO Annex 17 2022. To minimize the risk of each occurrence, airport measures systematically replace equipment with new ones, responding to current threats in civil aviation. Today, air transport is growing annually. To be characterized by a sufficiently high level of safety, they must have a large number of safeguards against situations that may threaten the safety of passengers. With the growing threat of unlawful interference and terrorist attacks, The widespread of using controls on people and baggage and airport is increasing. The airport is a place that requires sufficiently high standard. Providing such protection is possible thanks to the appropriate devices and employees. Depending on the geographical situation, available resources, technical equipment, level of stepping training, number of mistakes made, and the level of the street, different devices, regulations, and control are applied at a given airport. Due to the difference between the airport and the other transport infrastructure, many factors should function differently. The human factor and its impact on errors are important. The people who care about airport security must have appropriate training compared to security personnel who work in other modes of transport. Additional skills and knowledge are required from airport security. In addition to basic qualifications, they must be characterized by having appropriate psychological predispositions. Compared to other security personnel, airport security are distinguished by much better time to motor coordination as well as perspectiveness. A particularly important position in airport security is occupied by the control of checked baggage placed in the hold. This is a job that requires quick decision making and in particular maintaining a state of high focus for a long time. It is primarily intended to prevent the transport of prohibited materials. Methods used include the use of various types of detectors and devices to detect traces of explosives or X-ray equipment. A device that analyzes the composition of liquid gels, aerosol, and signal the content of dangerous substance with an alarm is also becoming more and more popular. Another important element is control of travelers and employees. The most common methods are multi-purpose detectors with the ability to detect various types of substances, metal radioactive materials. However, in addition to standard devices, there are also more advanced solutions. One of them is the GE Entry Scan Gateway. This device works by emitting a blast of air-moved particles on the skin or clothes of the test subject. After motion to the particles, they are intercepted by gauge sensors that subject them to air analysis in search of traces of explosives. The increasing threat of acts of unlawful interference and terrorist attacks result in an increase in the amount of security and accuracy of control at airports. The most important effects include a decrease in the comfort of traveling for customers and a decrease in the capacity of terminals. In response to this, special models are created that, through the analysis of various elements mentioned earlier, are able to help in choosing the appropriate control variant depending on the current situation. However, it is impossible to determine this relationship in the strict and precise way, so it is necessary to use methods adequate to the situation specific to the case when we have imprecise, uncertain, and subjective information. However, even in less specified situations, performing such as an analysis helps to determine, as far as possible, the optimal selection of the control method at a given airport. Unfortunately, conventional airport screening tests focus on identifying items that are illegal or dangerous to flight security. However, according to IATA, it is crucial to use analytics and behavior controls to spot people with bad intentions. Regardless of baggage IATA, there are at least a few practical approaches to recognize a questionable person in an airport terminal, but all rely on human labor. This is understandable, therefore, because identifying a person with bad intentions is based on psychology. A solution streamlining the process could be implementing a psychological model into AI based on suspect among criminal offenders. Specialized software could assist airport security services in the form of identifying specific behaviors that would be the rationale for conducting more detailed security checks on specific individuals. 1.2 Development of the CCTV system. The subject of the analysis in this paper is assessment of the impact of use of modern digital image processing, analytics, and its use of a specific work environment on improving airport security. Airports that have a camera system are placed where security issues are taken into account in a special way. The most important advantage of a monitoring system is that the operator discreetly has the opportunity to observe the behavior of passengers who often are unaware that they are being supervised through their behavior revealed their true intentions. In addition, properly placed cameras allow surveillance over the extensive infrastructure of the airport, which is not without significance for the personal planning or security staff. In addition to the above advantages, CCTV also has the ability to recording images, which in the event of an alarm, allow for faster assessment of the situation or risk analysis related to the event, along with development of cameras and the need to provide monitoring of an increasing area of given infrastructure. This technology, like other airport security equipment, has evolved towards supporting the work of infrastructure monitoring operators in the field of automatic detection of event potentially threatening security at the airport. Thanks to the modern system, the operator received newer and newer possibilities. A big change in the operation of cameras was the use of PTZ cameras, which made it possible to reduce the so-called blind zones, i.e. points that the cameras could not reach. In the event of an alarm, it also improved the operator's situational awareness, as he could see much wider area. Other improvements significantly improving the effectiveness of monitoring system were the ability to zoom in and play back the image recording from a particular camera. There is also a problem with the CCTV system. It requires the qualified camera operators to supervise the recording process and describe the suspicious activities. It is not possible to detect all the incidents by human morals. To increase the effectiveness and efficacy of the process, it is necessary to make use of modern technology in conjunction with the IT system and human works. CCTV can give much better action efficiency. The computer vision software has a very large number of functions. On the example airport monitoring, let's use an example of the person wrong direction function. It triggers an alarm when a person moves in the opposite direction than the direction assumed by the operator. At the airport, this applies, for example, in the case of security checks, where cases of passing in the opposite direction are rare. This allows you to capture the person who is trying to bypass the security checks without having to constantly monitor the screening by the operator. Another function applicable at the airport is a search for baggage and passenger aligned to it. Airport on Poland bombs a lot caused by the unattended luggage are very common. Thanks to the computer vision software, we can find the owner of the baggage by searching for him on the other cameras. One of the major achievements that had a key impact on camera systems was the invention of digital photography. Until recently, analog photography was the only technology that allows for image recording. Today, the vast majority of cameras are digital, which undoubtedly contributed to the development of AI software for analyzing the image of the camera. These cameras are characterized by much better parameters, have variable focal lengths, digital and optical zoom, and even change exposure parameters. This opens up many new possibilities for both people and specialized computer programs dedicated to image analysis. Several types of modern vision systems can be distinguished. These are easy thermal image gate and motion day-night cameras operating thanks to the IR LED. but also cameras differing in parameters such as sensitivity, angle of view, or power consumption. All this can increase monitoring efficiency under various operating conditions, such as low light intensity. However, these systems have their limitations. The increase in popularity of the aviation branch of the communication required the expansion of the terminal infrastructure, which each turn requires the inclusion of it with mandatory supervision. Measures can achieve these goals in two ways. The first is to increase the number of physical security staff, and the second of expand the CCTV system. With the above in mind, attention should be paid to the possibility of using an alternative solution based on a technology that significantly reduces the human factor. These psychological conditions of the operators are limitation of the work on the monitoring system. This job requires maintaining a high level of concentration for a long time, but research shows that after 20 minutes, a person loses 95% of their attention. The answer to the problem described in the paragraph above is computer vision. This is technology that allows you to distinguish objects in the form of digital image, video, or photo. Thanks to image analysis, the computer is able to recognize various types of objects. People, luggage, motor vehicles. There are two types of the devices using computer vision, and those are devices that analyze the image in real time and are based on archival recordings. The computer vision software has a very large number of functions. As an example of airport monitoring, let's use an example of a person wrong direction function. It triggers an alarm when a person moves in the opposite direction than the direction assumed by the operator. At the airport, this applies, for example, to security checks, where cases of going in the opposite direction are rare. This allows you to capture a person trying to bypass security checks without having to constantly monitoring the screen. Another useful function at the airport is a search for baggage and passenger assigned to it. At the airport in Poland, bomb-related caused by unattended luggage are very common. Thanks to the computer vision software, we can find owner of the baggage by searching for him on other cameras. Taking into account economic and safety aspects, the potential is gradually being implemented in critical airport infrastructure. For example, when touchable technologies were unwelcome during the pandemic, facial recognition was eagerly introduced. Deployment of such systems would not be possible if the technology of vision systems based on 2D, 3D, and thermal image cameras will not be available. Face recognition not only enables faster inspections but also improves their accuracy. Second, methodology. Current monitoring systems are being used to increase security and maintain public order. CCTV systems, closed circuit television are implemented in most public places, with particular attention to areas with an increased crime risk, such as airports. For the sufficiency effectiveness of the system, in many cases it is supervised in real time by adequately qualified people. Dedicated software based on AI and machine learning is increasingly used to support the operator and increase the effectiveness of crime detection. In addition, it optimizes the use of potential of vision systems. The planned research was aimed to determine the possibilities and scope of application of selected AI cameras to support the airport security monitoring system operator. They were carried out on the example of the following companies: Mobotics, independent camera M373 with dedicated software AI loitering, the purpose of which is to detect people on designing drone, assigning them a number, and thus monitoring how much time a certain person stays inside this zone. Using this software, it is possible to find people that are loitering. A camera of this type is also capable of running AI's analysis such as object detection, AI crowd deep counting, AI intelligent pro, AI crowd technical specifications of Robotics M73. These are some of the possible firmware for this camera that we did not have access to. Every software based on existing system of the Cyclowise Airport. This is one of the programs designed to support the works of the camera operator. It has many analytical functions covering various areas related to sub-airport security. During research, we focused on retrospective detection of people based on their face and crossing between different cameras. We use similar function to find the luggage. 2.1 Place and time of the research. Practical testings were carried out in October 2022 in Terminal B of the Katowice Cyclowise Airport. The time chosen for the test was well throughout. The tests were carried out on the day with low passenger traffic. This decision makes it possible to avoid recording people not participating in the experiment and obtaining the most reliable result. In the case of the Average software, the tests were carried out passengers at the airport, while the trials of the Mobilex camera and software were carried out on simulated situations by an airport security employee. Mobile's M713 camera, it already has built-in analytics, therefore it does not require additional system elements, such as existing system infrastructure server. Unfortunately for this region, the number of analyses carried out at a given time is limited. The camera can only use on one analysis at a given time. The Mobotix M73 high standard modular bispectral camera in M73 up to 3 different sensors can be installed depending on your needs. These modules differ in resolution, being angle, focal length, camera type, thermal camera or application, IR diodes for night recordings. From the available analytics, the AI loitering software was chosen for the test. This analytics is designed to detect the so-called wandering around. Depending on the set time of parameters, a person after a given time may be considered a suspect of wanting to commit a prohibited act. In order to conduct research, the camera was placed so that it could cover the entire area of queue entering the security checks, limited by the tape. The only person in the designated area was an airport security officer who moves around a large part of that area and stood in various positions, front, side, and back to the camera. This allows the performance of the camera to be tested under various conditions. Camera internal program, in accordance with the manufacturer's recommendations, was set to a time of tense, meaning that in order for a person to be detected, he would have to stay within the designated area for at least 10 seconds. Averaging software is software connected to the existing networks of cameras designed to analyze the image in terms of various analyses selected by the operator to increase security in the area covered by the monitoring. The main goal of the program is to reduce the operator's workload, which results in increasing the level of facility security. It is used easy in the protection of critical infrastructure. The functionality allows to notify the operator about the occurrence of the given situation, as well as indicate the image from the camera tracking the event, leading to faster intervention of security personnel. It is also possible to reverse search people and objects based on their appearance, color, facial appearance, shapes. This feature is able to help determine the location of the object of person, which can be evident value of law enforcement. Aviation website. At the airport, Cyclowise 3 functions of program were tested, searching for people based on faces, searching for people based on clothes, searching for baggages based on appearance. An identical scheme was used to each function. An exemplary person object was selected. The program searched for all persons object meeting the search conditions, all cameras, and within specified period of time. And the rating of the effectiveness of the program was manually checked by determining how many of the searched images should the person object being searched for. Result. The complete result of shown separately for both functionalities. M73 camera. During the 1 hour testing period, the software reported 19 situations. As it is seen in figure 1 and 2, there were light reflections from the windows of the airport terminal inside the test zone. Such conditions resulted in situations of the lost tracked person. Additionally, the software informed the monitoring operator in real time about detecting the circumstances by the appearance of the clearly visible frame around the image from given camera, and then recording it in the event history. Sometimes, when person was not visible enough to the camera lens, left the camera field of view and returned to it. The camera would often shoot the person as a new one. Evaluation software. The functionality tested with Evaluation software enables the study of the entire airport area, even outside the terminal after locating a suspicious object or person. The monitoring operator must indicate it on one recording image. The system presents the selected object at other times on the cameras. Possible marks are shown in the photos to give the security person an option to choose the point of interest. After selecting a given scene, the software shows greater amount of the indications in each setting. It is also possible to search for people based on given color of clothes, gender, or age. Such as an example is presented in figure 4. The system enables locating the searched person in a large area and tracing the history of his behavior. The functionality was most effective when indicating the plain color of the person's clothes or the objective being searched for. Conclusions. Functionality of the selected system. Two different functionalities were selected for the research to support the monitoring operator in order to make the research result more comprehensive. Functionalities with a different mode of the operations were chosen from two different manufacturers. The basic differences are outlined in Table 1. The presented table illustrates the basic principles of operation of the camera functionalities being tested and also allows for easier understanding through direct comparison. Difference between functionalities, source homework, system, type of functionality being studied, and each mode of operation, area of operation. A camera with a built-in analytics, real-time video analysis, and signaling of potential security threat. Field of view of one camera. Software based on existing system. Searching for specified person object on already recorded materials, as indicated by the operator. Searches for objects from all available cameras in the system. It should be noted that the ability to use existing system infrastructure for research was a major advantage. Not only does this increase the ability to analyze it in more comprehensive way, but it also allows for the use of the system, for example during the search for materials, persons, and has evidently value, which is important in the case of critical infrastructure such as airport. The use of a single high-resolution camera, however, shows that significantly better image qualities allows for more effective, faster, and less unreliable operations of the system. This is particularly significant in places with a large number of people and large number of various parameters. Both of the functions studied have demonstrated the importance of property selecting analytical parameters for systems in correcting assumptions in the environment, which deviated significantly from the laboratory conditions, can cause false alarms or fail to detect dangerous systems. Final conclusions. The diversity of functionalities of visual materials and analysis software available to support the monitoring operator allows for their adaptations to the individual needs of the user. Analyzing some of these functionalities can be concluded that each of them can be considered useful. However, they are not infallible and require further improvement and development in order to personalize them to specific conditions of the protecting infrastructure. Starting from the most general conclusions related to functionality of the CCTV system, it should be emphasized that expectations have been formulated for the system to meet the basic assumptions in every environmental settings. For this purpose, it is necessary to test and define the expected functionalities. Additionally, this system can provide comprehensive analysis of the materials, as it can cover the entire area of the infrastructure under study. Unfortunately, in many cases, the cameras used in the systems do not have sufficient visual parameters, especially regarding camera resolutions. This leads to the next conclusion that before introducing and implementing specialized software, the existing CCTV infrastructure should be modified. Having properly adjusted the infrastructure, one can introduce and develop existing software on the market. These are universal software and can be used depending on the goal that the infrastructure manager wants to achieve. The drawback of the university is that in the case of more specific, tight, defined environment, such as in airport, the software should be strictly dedicated and tailored to its specific conditions. Streets and airport and many other critical infrastructure facilities are different, and the people's behavior is strictly defined and occurs only in the specific situations such as during a security checks. AI applied in visual systems in order to support the monitoring operator is a future-oriented solutions can indicate the direction of further development and evaluation of the airport security systems. It minimizes the influence of human factor, and also provides a constant level of analysis of the designated area and specific situations. This has a significant impact when considering the human factor, which can only control a few places at a time with expected efficiency. In addition, despite the relevant courses and the training of the technical nature, each officer pays attention to other aspects that are premise for potential criminals act. For these at the moment, he usually uses only the experience he has gained in the course of his work. Increasing the number of surveillance operators and security officers is also not the target solutions due to the inability to maintain constant level of vigilance of people and the significant logistical and financial burden on the company. The advantage of using analytics based on the AI it can learn from the all past event, thus improving the system to detect all situations that are potential threat to airport security. As another advantage in implementing such a system, one can point out the absence of the human factor, which means that this type of information system can constantly analyze the entire airport area with the same precision and efficiency.